Yeah, well, let's just give you a little look at interlacing plasma fields. Just to give you an idea where we're going to go. You can guess which one is the sun and which one is Earth. Okay, let's just go back a little bit here. Get to the right screen. Oh, what do we got here? Why, that's the Milky Way. Oh, there's the Sagittarius dwarf galaxy. That's Earth there. Ooh, see it? Earth, 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 Earth. Black hole. Ooh. And we're at 60 million. Oh, did you catch that? Oh, here, let's give you that again. Check. Kind of screwed it up for you. Oh, here, let's get the sun out of the way.
My phone's rung off the hook. Emails, I know you've gotten it, saying this had to be hard.
Piece of shit. Not you, Alex. What they've managed to do to this. Google Tube. Okay, there we go. We'll give you that one more time. Guess I better give this guy credit too. Yeah, see? There's Earth. $1.3 million. Okay, watching. Okay, this is where the galaxy gets a little fucked up. Oh! Oh, no. That's a biggie. This deflection doesn't show it. It's only rough. Oh. There you go. Anyhow. There was the last big marriage. Let's just have a good look at the sun here. I think this one does it. That's the sun. Oh, there goes Earth. Oh, I forgot to give credits. There's a look at the sun. We're going to get a look at the heliosphere here, I believe. There we go. See? That's kind of... Let's see, the globe's starting to... That's about one light year out. Right, see? Heliosphere. It's not really shaped like that. And of course, we spiral through space. Just like the sun does, and we follow the sun spiraling through space. And our galaxy spirals through space. 1 year is 250 million years, of course. Not Earth, it's 365 days. 250 million of those is... That's our sun, our astrosphere. That's how long it takes to go around Sagittarius A at the center of the Milky Way. Which will be sending us something our way pretty quick, most likely. As in, like, a month or two. Okay, now, you can see... Oh, there's a... Whoops, shit! We had Nibiru there. Just when things were getting good. Sorry, guys. That's NASA. I'm just using their public works, and of course, because YouTube is such good garbage, you can't actually do anything with it. Okay, we're back again. So, there you can see the astrosphere. This is where Voyager 1 is, and this is where Voyager 2 is. Okay, now, there's a massive globule, about 3.8 light years at the widest. It's kind of shaped like an amoeba. Okay, we'll get to that. That's from a supernova remnant 3 million years ago, and it's when it abrades here against the astrosphere, you get distortions, you get energy buildup. That's a big gravity mass, by the way. That's not what they're actually depicting here, so sorry NASA, I have to bastardize your graphics. So this is not NASA saying this, right? This is me based on others' research. Now, I don't think this will show it, but when this flips sides, then just like we're going to show you here on our little make-believe astrosphere. Hopefully I can get back to a black screen. It kind of depicts it moving through space, and you can see the different densities of the clouds, of the local interstellar cloud. Generally, there are large lumps of it in there from the blown-up supernova. It's not homogeneous, like some parts are thicker, and when you go near the edge, then you always get a big buildup, just like you see depicted here, where energies kind of balance out, and masses, right? All that gas gets thicker here and energetic. It actually boils into a magnetic froth and generates its own electricity by the very fact that it's moving like a surf. It's actually moving faster than the whole thing is moving through space, and each medium is a different magnetic field, just like in your alternator, how you, well, not just like, but sort of like in an alternator or a generator, right? You have two opposing magnetic fields, and where they pinch, well, of course in space you can have 3 or 4 or sometimes 5 interlaced electromagnetic fields. Are you ready? I don't know if there's anything more in here, but it's kind of neat, so we'll just go with it. Nope. Let's see if I can give you a close-up. Crappy camera setup. There's your star. There's our soul. So you kind of get the idea of Nibiru, and it can come and go. When it starts to come lots, well, you know that there's an awful buildup of gas being turned into hot energetic plasma as Soul's atmosphere and the atmosphere of the supernova remnant, which is way big, way bigger now. That's just like a little globule of a cloud that's we've been going through for 80,000 years, as I've explained before. Yeah, this is kind of a supernova. Again, credits go to Asinova. But I think this is a Chandler X-ray. This is just a supernova, a younger one. Right, so that's, from a little wee star that you couldn't even see that blowed up. Right? All the gas, that's what we're going through, and it distorts as it encounters other gravitational bodies and other forms of mass and energy.
New research.
So, let's get back to what I really want to show you. That's going to fuck this up, isn't it? Maybe not. Yeah. It's good as something black. There. Alright, that's better. Okay, here we got the sun. Here we got the Earth. Does that look better from here? Okay, just use your imagination a little. See where they're connecting? Okay, this could in fact, this one is now the sun's astrosphere, and this is a big globule from that supernova remnant, the local interstellar cloud, right? Okay, so here it comes along. Here's the batteries are weak in this one, so it's not putting out much. That's the sun. That little dot in the middle. And that's the interstellar magnetic connectivity, right? All this. As it's trying to balance out its energy with the local whatever's happening around it. Because energy seeks a balance, and mass seeks to amass, right? Like in a black hole, or like in a planet core. Okay, before the sun dies. Okay, we'll see it picking up. It's actually getting energized as we get closer to dense energetic globules in the local interstellar cloud. Right? This is the interstellar cloud, right? And here's the sun. Or you could say vice versa. Oh, you see Nibiru there? Right? Where the two plasma fields interlace? You see that? Oh, I better not get too close to the camera, it'll zot it. Oh, now Nibiru's gone. Well, fuck, it was a planet coming in, and, you know, like a asteroid coming in through our atmosphere, through the thermosphere, and it burns up and off gases, and the energies balance out and create plasma. Well, how could Nibiru be there? Not there. Nibiru be there? Not there. Be there? Right? By the way, Astro Ouroboros, the snake eating its tail, that's a symbol for when a galactic core burst happens. You know, basically that's the renewal symbol for a galaxy. See how they connect? Let's see if we can show you better. Some more effect in our make-believe magnetosphere and astrosphere. Here's a magnet. See how it pulls all the plasma to one side? Right? Like if say another planet or even a comet or something was coming in, you see what it does as it's penetrating, right? Because their energies are the potential is trying to balance out, and that's energizing all the gas, the hydrogen, and all the stardust, and it's making it glow. Just not all that different than when Aurora Borealis lights up the sky as the gases energize and ionize like your fluorescent light or your neon light. Now let's see if we've got enough power left in this puppy. I'm going to have to turn them both way down. I was going to try and, okay, we've got Earth all, let's put Sol out of the way here. This is now Sol again, right? And this one is Earth. Oh no, come on, don't die on me now. At a bad time. Okay, hang on, I know what we can do. Bear with me. Okay, I'm going to switch planets here. That's now Earth. There we go. Okay. That's the sun. Earth will settle down in a little bit. It's just been hit by a bunch of CMEs or space weather. See, there's an asteroid coming in. See how it changes? The plasma tends to concentrate over there, and it deprives the lightning storms on the other side of the atmosphere of Earth. Right? Okay, there. The space weather's all over. Oh wait, there's a CME coming in here. Where's my big magnet? Here comes the CME strike on Earth. And it's all, say it's all over Asia there. Okay, you see how it affects the electromagnetic ambience of the entire magnetosphere? Right? Because plasma fields do connect. And try and balance out. Now, I'm going to try and show you why there's less going off of CMEs, okay, pretending now we're at the sun again. And say this is a year's worth, and all these are CMEs and coronal discharges, right? All these little tendrils of plasma discharge. Okay, so pretend those are CMEs. Now watch what happens. There's a little Earth with its much weaker magnetic field. I think we have to turn it this way. And of course its magnetic field is being altered because just like these fields can interlace. I believe we need a little inducement here. It goes right through into the core, which is the major dynamo of the Earth, right? The atmosphere movement and the ocean movement is just a small generator. The molten metal, hot molten metal, super dense metals moving inside the Earth is big time. Okay, I don't know if I'm going to be able to do this today because I was waiting for a big enough solar storm or the third level, the local interstellar space, or the air in this room and the sky had quite a charge in it. So I'm trying to show you. So there's interplanetary magnetic connection, which does influence the way CMEs when they'll trigger, and influences the direction and speed that they'll flow. Right, that's why one time it'll be reverse polarities and nothing will happen, and another time it'll rip the magnetosphere right off and get pulled back in from the far edge of Earth's magnetosphere on that snap effect, or else another one will come in at the same time. And now thinking along the way these interact, now pretend one is this is a CME, and just like a few days ago, why didn't all that CME hit as well as a week ago? Well, because Venus was in the way and acting like a capacitor. Right? And here's the CME, and you can see, whoa, it's changing everything about the CME depending on the polarities and the strengths and a whole lot of other shit. So they do interact. Sorry, I couldn't quite show you what I wanted to. Conditions aren't right, but we'll try this again. To where, well, how come CMEs are so much less prone to hit Earth? There's a big one, and it's just like it settles down when it gets in the interplanetary connectivity zone. Sometimes it actually agitates it, depending again on the polarity, and sets off that CME. But in fact, because they influence each other, the electromagnetospheres between the sun and the Earth, not even in the picture. It can in fact have a damping effect until that big sunspot gets out of the influence and reconnection happens elsewhere, and then kaboom, CME. That's why you've been noticing lately, especially when conditions are right, it's more prone to actually dampen the need for the sun to let a CME loose. Keep in mind, a CME is a energy and matter imbalance, and they have to, one has to mass and one has to balance out. So, well, easiest way is path of least resistance is right out through the coronosphere, and if you happen to be in the way and connecting magnetically, well, then you're gonna get it. There. Can we do that? No. Well, I'm sorry, I had a lot of trouble, so we'll try this again. These aren't very much. You can usually get them for 15 to 25 bucks. And all kinds of different sizes. And they are a good visual aid because they're plasma. So, you can get a little idea how they interact. I'll try and get back to you later on this, when I can make it work again. Nibiru! So, Nibiru could be called kind of like the Aurora Borealis. Now, if you get the massive energy discharge from a large event at the galactic center, Sagittarius A, like gas cloud 2, whatever may or may not still be in it, well, the results, like I said, should be here anytime. If there's a lot of dense stardust cloudlets, charged the right way and of the right kind of elements, abrading and colliding and reacting with our star's atmosphere, with Sol's astrosphere, which is its electromagnetosphere. Well, then instead of just having full deflector, that extra energy coming in can very well push a bunch of that shit right in through our star's protective thermosphere. That's not what it's called, but it acts the same way.